Hello, geometry people. We're going to study the Pythagorean Theorem today. I think it should be reviewed, but with coronavirus, you never know. So the Pythagorean Theorem states for a right triangle, if the legs are donated as A and B and the hypotenuse is C, then A squared plus B squared equals C squared. This is the Pythagorean theorem right here. A squared plus B squared equals C squared. Works for right triangles, and the legs are the two sides that are next to the right angle, and the hypotenuse is the long side that is across from the right angle. So let's see an example of how these problems work. Here's our first example. If the legs of a right triangle measure 3 and 4, find the length of the hypotenuse. Well, if the legs are 3 and 4, they get plugged in for the A squared and the B squared. So this would be 3 squared plus 4 squared equals the hypotenuse squared. Now you can use the letter C if you want, or you can use the letter X. It really doesn't matter. Let's use C for C squared, since I plugged it 3 and 4 in for A and B. Now, to solve, 3 squared is 9, 4 squared is 16, that's C squared. 9 plus 16 is 25, and we've solved for C squared. When you do these types of problems, it's just like solving normally, except you solve for the C squared, or the X squared, or whatever the variable is squared, and then you have one last step. To get C, you have to square root it. So you take the square root of 25, and that's going to equal C, because the opposite of squaring is square rooting. That's how you get rid of the exponent of 2, you square root it, and the square root of 25 is 5. And there's our answer. Let's take a look at another one. This is a right triangle. You can tell by the box. One leg is 5, one leg is x, the hypotenuse is 13. So we're going to use the Pythagorean theorem to find the missing side. Now that missing side is a leg, so I'm going to plug it in for the A, and I get x squared. 5 is the other leg, so that is 5 squared. And the hypotenuse is 13, that's 13 squared. When you're plugging into the Pythagorean theorem, it doesn't matter which leg gets plugged into which, A or B, it doesn't matter. Just as long as the legs are A and B and the hypotenuse has to be C. Okay, we're going to keep the x squared. 25 squared becomes 25. 13 squared, if you use your calculator or if you know it, is 169. Now let's solve this like it's a regular equation, minus the 25 from each side. Bring down the x squared equals 144. And then our last step is going to be take the square root of 144, and that will give us our x, and x is equal to 12. Now, last class we learned how to simplify radicals, and that gets used a lot in the Pythagorean theorem too. So let's take a look at a couple of examples where we have to simplify. First example says that the legs of a right triangle measure 2 and 5, find the length of the hypotenuse in simplest radical form. Okay. So if I'm going to use the Pythagorean theorem, a squared plus b squared equals c squared, if the legs are 2 and 5, they get plugged in for the a and the b, and we're trying to find the hypotenuse. Well, if I square, I get 4 and 25. Add together, I get 29. Then if I square root it, I get the square root of 29 equals c. So now we have to simplify this. So if you recall, you need to know your perfect squares, and I'll just write a few over here, 4, 9, 16, 25, etc., etc. And which one of these numbers goes into 29? Well, none of them do. Nothing goes into 29. 29 is a prime number. So, we can't simplify, and we're actually done. 29 is the answer in simplest radical form. Now, let's do one where we do have to simplify. Same problem, but our legs are now 4 and 6 this time. So we get 4 squared plus 6 squared equals c squared. 16 plus 36 equals c squared. 16 and 36 equals 52. So let's do the square root of 52. Now, to simplify this, which one of these numbers goes into 52? Well, 4 does. 4 goes into 52 how many times? 13 times. So this becomes the square root of 4. Square root of 13 equals c. And the square root of 4 is 2. And this is the answer in simplest radical form. Okay. Good luck with your assignment on the Pythagorean Theorem.